Okay, let us start. Welcome to the CRT YouTube page. Our topic for today will be about the power series. Today we will discuss the two most common power series topic, which is the Taylor series and the Maclaurin series. Now, according to the definition of the Taylor series, the function f of x can be expressed as the summation of x minus a raised to n f of n sub a all over n factorial from n equal to 0 up to infinite. The a here, that is equal to the what we called center of Taylor series, while the f parenthesis of n of a, this is the nth derivative of the function f of x, whose x is value is equal to a. Now, before we go to the shortcut of the Maclaurin, or rather Taylor series, we all know, and according to the definition, if a is equal to 0, or the center of the Taylor series is equal to 0, we could say that the Taylor series is equal to the Maclaurin series. And by substituting the a from the equation, this will just be have to derive the four most common function that has a standard format of the Maclaurin series, and those are the Euler exponent e sub x, sin x, and cosine of x, which is equal to the summation of x sub n over n factorial, or the e sub x, up to 0 to the infinite, while the sine, that is summation of n equal to 0 up to infinite of negative 1 raised to n, x raised to 2n plus 1 over 2n plus 1 factorial, while for the cosine to be summation of n equal to 0 up to infinite of negative 1 raised to n, x raised to 2n, all over 2n factorial. If you could notice, all of the limits of these two series is up to what? Up to the infinite. That's why they are called power series. Okay. Now let's try some example of the Maclaurin series. For an instance, we are said to find the Maclaurin series of sin 2x. Now, how do we find the Maclaurin series of the sine 2x? Step 1. Earlier, I've discussed the three most basic equation of the Maclaurin series. You must memorize these three basic equation, which is shown on the left side of the video. The e sub x, the sine x, and the cosine sub x. Now, first of all, what is the equation of this one? This is sine 2x. So therefore, we will use the format of the sine x, wherein the x here, we will substitute it to become what? 2 sub x. In doing so, our step 2 will become summation of n equal to 0 up to infinite, negative 1 raised to n. Now, the x will become 2x. All of them will be raised into 2n plus 1, all over 2n plus 1 factorial. Well, this is enough already for the answer. In addition to these three most basic Maclaurin series equations, I will introduce another equation which is derived from the geometric series equation. If you will recall, the sum of the infinite geometric series is equal to what? This is equal to a sub 0 all over 1 minus r. Now, if we will apply the rule of the power series, we all know that the upper limit of the power series is what? They are all equal to the infinite. In doing so, we could clearly say that the function f sub x could be equal somewhat to this format. So if we try the for f of x, which is equal to 1 all over 1 minus x, they are somewhat equivalent to each other, wherein the a sub 0 for this equation is equal to 1, the r is equal to the x. And if you will recall the format of the geometric sequence, we could write also the sum into the summation of a sub 0 r raised to n, wherein the value of n is from 0 up to the infinite. While this equation on the left side, or rather on the right side, we could rewrite this into this format. So this will be the f of x, or this equation above can be also expressed as summation of n equal to 0 up to infinite. What is the a of 0 for this one? That is 1. What is the r? X. And we could say that this is x raised to n. Earlier, I have an example of the Maclaurin series. Now, we will try the 3 steps in computing the Taylor series given the standard equation of the Maclaurin series shown at the left of the video. Now, what if we are asked to determine the Taylor series of the function f of x is equal to e to the 3x, whose center at x equal to 4. Now, we could use the 3-step method here. But first, in order to use the 3-step method here, you must memorize, again, the equations at the left of your video. Step 1. The step 1 here is to determine the Maclaurin series of the given equation. Now, what is the Maclaurin series of e to the 3x? This is equal to, by using the e sub x there, this will become to the summation of n equal to 0 up to infinite of 3x raised to n all over n factorial. By distributing the exponent n, we could clearly say that this is summation of n equal to 0 up to infinite of 3 raised to n, x raised to n over n factorial. Step number 2. All x must be shifted to what? If we equate the center x equal to 4 to 0, this will become x minus 4 equal to 0. In other words, we must equate the center to 0. Then, all the values of x will be shifted up to that equation. So therefore, by using the equation of the step 1, this will become summation of n equal to 0 up to infinite of 3 raised to n, x minus 4 raised to n, all over n factorial. The last step would be this one. We need to substitute the center to the given equation. What is our given equation? E to the 3x. What is the value of the center? X equal to 4. So now we will be substituting the x equal to 4 here, giving us an e raised to 3 times 4, giving us an answer that is e raised to 12. Now, what will be our final answer? Therefore, our final answer would become this equation. This third step, we will multiply it to the answer at the second step. So, the answer, I'll put it here. Therefore, our answer will be summation of n equal to 0 up to infinite of 3 raised to n, x minus 4 raised to n, e to the 12 all over n factorial. This will now be our Taylor series of the function e to the 3x, whose center at x equal to 4. Don't forget to like and subscribe the CRT YouTube page. Thank you.